3b is add, subtract, and multiplying radical expressions. Example 1, simplifying. So we're just adding these two radicals, 4 square roots of 7 plus 2 square roots of 7. So I have 4 square roots of 7, and I'm adding 2 square roots of 7. So total you have, they're like terms, there's square roots, and 7's underneath. So total you have 6 square roots of 7. And that's it. Moving on. Simplifying now again, we have the square root of 24. First you need to simplify the square root, unless you have like terms, which we don't. So biggest perfect square that goes into 24 is 4. So that comes out as square root of 4 is 2. Square root of 6. Biggest square root, perfect square divided out of 8 is 4. So that square root of 4 is 2. Square root of 2. And then the cube root, biggest cube root that goes into 54 is 27. So the cube root of 27 is 3. And then it's a cube root of 2. Look in to see if we have any like terms. We have square root of 2. And that's not the same thing, because this is a cube root of 2. And we have a square root of 6, but that's not a square root of 2, so that's not like terms. So this is it. That's your final answer. No like terms. Everything is simplified. All the terms are simplified as far as they can. And that's your final answer. Moving on. We have the square root of 32x squared plus 2 times the cube root of 16x squared minus 3 times the square root of 128x squared minus the cube root of 24x cubed. So I don't see any like terms right now. So all the variables have to be exactly the same in the exact same spots, and it has to be the same root. So let's simplify first. So square root of 32 is 4, and then x squared is, or square root of x squared is x, and then what's left over is the square root of 2 plus 2 that's on the outside here. Cube root of 16, the biggest perfect cube that can divide out of that is the cube root of 8, which is 2. We have x squared, which there's 2 x's. We need 3 of them, so that does not work. Cannot simplify that. So what's left over is the cube root. So there's a 2 left over from the 16, and the 8 that came out of it, and x squared. And then we have subtracting 3. And it's times here, so it's going to be multiplied by, and the square root of 128. The biggest perfect square that can divide out of 128 is 64. And the square root of 64 is 8. And the square root of x squared is x. What's left underneath the square root is just a 2 from the 64. Times 2 is 128. And then subtract cube root of 24. Biggest cube, perfect cube that divides out of 24 is 8, and the cube root of 8 is 2. And cube root of x to the third is x. What's left over is a 3 from the 8 times 3 is 24. Now, let's just, all these terms, let's simplify them a little bit. First term, nothing to simplify. 4x square root of 2 plus 2 times 2 is 4. Cube root of 2x squared minus 24x square root of 2 subtract 2x cube root of 3. Now I'm looking to see if there's any like terms. So they get like terms, you have to have the coefficients have to be, the variables in front of the radicals have to be exactly the same, and underneath the radical, and the type of radical all have to be the same. So this is x square root of 2. There's no x here, and it's a cube root, so it's not like terms. X square root of 2. So that, like terms here. So we have 4x square root of 2 minus 24x square root of 2. That is a negative 20 x square root of 2. Then we have 4 cube root of 2x squared and 2x cubed root of 3. Those are not like terms, so we just write those down. 2x cubed root of 3. And that's it. Moving on, let's move on to multiplying. So when you're multiplying, you don't have to have any like terms. You're still just putting them together. So you have, in this case, square root of 15 times 4 is 4 square root of 15. Square root of 15 times square root of 5 is the square root of 75. And now you look to see if you can simplify. So you have the square root of 15, does not break down. So 4 square root of 15. Square root of 75, biggest perfect square that divides out of 75 is 25. Square root of 25 is 5. And 25 times 3 was 75, so that's there. Not like terms, so this is the final answer. Moving on. Let's skip 5 and go to 6. Example 6, we have a binomial times a binomial. So sometimes it's easier if you were to color code it. So your first term is the square root of 5. First term over here is the square root of 5. So when we do square root of 5 times the square root of 5, that's the square root of 25. So you just multiply underneath the radical. And then you do square root of 5 times, I include this negative. So square root of 5 times negative 2 square root of 3. On the outside of the square root of 5, there's a 1. So you can multiply the outside, so 1 times negative 2 is negative 2. And square root of 5 times the square root of 3 is the square root of 15. And so this last term here, now we got the, I guess I didn't show that. So we're distributing. So negative 5 square root of 3 times the square root of 5 is a negative 5 square root of 15. Remember there's a 1 on the outside here, so negative 5 times 1, negative 5. And the last one, negative 5 square root of 3 times negative 2 square root of 3 is a positive 10 square root of 9. After you multiply it out, let's see if you can simplify any of the terms. Here, this term here, the first one is square root of 25 is 5. Minus 2 square root of 15. 15 square root of 15 cannot be simplified. Next one I see is the square root of 15, so that means those are like terms. So our next step is we're going to get these together. You could have done that there, but it's fine to do it the next step. And we do square root of 9 is 3. So we have 10 times 3, so this is 10 times the square root of 9. So next step, well, let's do 10 times 3. 30. 30 plus 5, 5 plus 30, 35. Negative 2 minus 5. This is negative 2 square roots of 15s, and you're subtracting 5 square roots of 15. That's negative 7 square roots of 15. And that's it. That's the final answer. Come to class with any questions you have. Thanks.